All right, you guys, we'll try this again. The software died about 5 minutes into this, so we'll try it again. Okay, when you're, I guess some vocabulary first. A times B raised to the C. A is a coefficient. It's something that's written in front of something with a variable on it. This is the base. This is the exponent. So when the bases are the same with the same exponent, you just add the coefficients. So that would be 5x squared. You don't change the base, you don't change the exponent. You just add the coefficients. These are like terms. Same base, same exponent. So you just add the coefficient. These are not like terms. The bases are the same, but their exponents are different. So nothing happens to this because they're not like terms. These are not like terms because the exponents are different with the same base. So there's nothing that happens there. These are like terms. Same bases, same exponents. So I just add the coefficients. These are like terms, so I just add the coefficients. When you're multiplying, so let's say I got x squared times x cubed. That's saying x times x times x times x times x. How many x's you got? 5 of them. So when you're multiplying, you add your exponents, and that's what I've got here, assuming the base is the same. Okay? I can rearrange this as 2 times 3 times x to the a times x to the b. This, you're just multiplying 2 and 3, so you just got 6. Then that's x to the a plus b as exponents, because you're multiplying, so you add your exponents. 5 times 6 is 30. X squared times x to the first, add them, so that's x cubed. Y to the third times y to the third would give you y to the sixth. I added them. Z to the third times z to the fourth, add them, and you get z to the seventh. Now, normally you would call these coefficients, but they have exponents on them, so you treat them just like a variable. So 2 to the c plus d times x to the a plus b. Right? Multiply the coefficients, add your exponents. X cubed, y to the fifth, z to the fourth. There are no other coefficients, so it's just 4. X to the first times x squared is x cubed. Y to the fourth times y to the first is y to the fifth. And there's no other z's, so you just got that. Multiply the coefficients just because they're fractions. You know, don't wig out on me and think you do something different. These are reciprocals, so you get 1. X squared times x to the first is x cubed. Y to the first times y to the first is y squared. When you're dividing, you subtract exponents. So let me give you another example that's concrete like this. So that would be x times x times x times x over x times x. These would cancel out, and you're left with x squared. So that's x to the 4 minus 2 is x squared. Now, this is going to bring up an interesting issue. If I have x squared over x to the 4th, that's x times x over x, 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 x. And you would cancel like this. The 2 are left down below. Now the book is always going to say, do your subtraction upstairs. Well, if you do that, you get a negative exponent. And we haven't talked about negative exponents yet. It means, in this case, the same thing as that. You're not allowed to leave a negative exponent as an answer. You have to deal with it. And we'll deal with negative exponents on the next screen. But what I want you to understand is, you guys know when there's more on the bottom or more on the top. If you just do the subtraction where there's more of them, so in this one I mean 1 over x to the 4 minus 2, you'll always end up with a positive exponent and never have to worry about what to do with it when it's a negative exponent. So do the subtraction where it occurs, okay, where there's more. 3 over 9 You guys don't need to know anything about exponents to reduce that. That would be 1 over 3. Here, there's more x's on the bottom, so do the subtraction on the bottom. 4 minus 2 is 2. There's more on the top, do the subtraction on top. 3 minus 2 is 1, and that's its exponent. Now, do you need an exponent of 1? No, I'm just doing it to illustrate the point. Okay. 2 over 8 is 1 over 4. Do I need the 1? No, not unless there won't be anything left upstairs. There's more 3's or more x's on the bottom. 3 minus 2 is x. 4 minus 2 is y squared. Okay. Reduce the fraction. There's a 2 in common, so that would be 8 thirds. X squared. Nothing else reduces, so it's z to the 5th and y squared. Okay, 18 and 24. What, there's a 4 in common? No, a 6 in common. So that would be 4 thirds x, y to the 5th. 3 goes into 18 6 times. X, the y's cancel, and z. Okay. Whoops, wrong click. Okay, guys, finishing this screen up. There's a 7 that'll, oops, yeah, because I did that one. 7 is going to cancel, so I have 3 and 2. X reduces, so I have x upstairs. A y reduces, so I have a y upstairs, and there's no z to reduce, so that's it. That would be your final answer. Okay, when you have an exponent on an exponent, like x squared cubed, that's saying x squared times x squared times x squared, which, as you know, is x times x times x times x times x times x, which gives you x to the 6th. So when you have an exponent on an exponent, the shortcut is that you multiply your exponents. Okay? That is an exponent of 1. 2 times 1 is 2. 2 times 4 is 8. You guys are welcome to leave it as 2 squared, or you could write 4x to the 8th. Okay? This would be 2 to the 2 times 3, x to the 4 times 3. Close the 4 off. First one, I think in a while. 2 to the 6th, x to the 12th. Multiply your exponents. If the exponent's missing, it's a 1. 3 to the 6th, x cubed, y to the 9th. I would be happy if you guys left it there. If you guys were to grab your calculator, it's going to be this humongous number. Let me type it in quick. 3 to the 6th. Okay. Maybe it's not that humongous, but my point being, you guys are welcome to leave it right there. 729 x cubed, y to the 9th. I'm happy if you guys get here. Okay, if you want to take it there, go for it. Your call. When you have a fraction, it doesn't change what you do. Exponents that are missing are 1s. Multiply them, so that becomes 2 squared x squared y to the 10th over 3 squared z to the 4th. If you guys want to leave a miss, 2 squared and 3 squared, that's okay. If you want to rewrite it as 4 ninths x squared y to the 10th z to the 4th, I'm okay with that too. Distribute this in. 4 cubed x to the 6th z to the 15th, 5 cubed y to the 9th. This one, go ahead and distribute the exponent in. 9, well, okay, hold on. I guess what I would like to recommend on this one is go ahead and write that as prime factored. So 3 squared x squared y cubed, 2 cubed z to the 5th cubed. Okay, so that would be 3 to the 6th rather than 9 cubed. Yeah, I don't. It's because that's factorable. I like this much better. Okay, x to the 6th, y to the 9th over 2 to the 9th, z to the 15th. Okay, and you guys don't have to type those in. You can just leave them as they are. I would be happy if you type them in. That's fine too. But I'm just saying you don't have to. Okay, negative exponents. As I hinted to earlier, Things that have a negative exponent actually mean a fraction. Things that have positive exponents, well, you've been dealing with positive exponents for years, nothing happens. This is the same thing as this. This is the same thing as this. If it has a negative exponent upstairs, it moves downstairs. Likewise, if it has a negative exponent downstairs, it moves upstairs. We're getting a little ahead of ourselves. If it has a negative exponent, move it and make the exponent positive. If it has a positive exponent, don't move it. This whole thing is being raised to the negative 1, so the whole thing moved. Here, the 3 had a positive exponent, so it doesn't move, it stays put. The x has a positive exponent of 1. It stays put. Whoops. But the y has a negative exponent, so the y is going to move downstairs, and the exponent becomes positive. So, it has nothing to do with the sign on the number. That's just negative 3. Negative 3 has been negative 3 for years, and you guys haven't had issues with it. So now that you learn about negative exponents, don't go crazy in the head and start making stuff positive or moving the negative 3 downstairs. No, that's not what it means. Okay? This one brings up you can't reduce it when it has an exponent. If you did reduce it, you'd get 1 over 3 squared, which is 1 over 9. The real answer is 3 over 81. 81 and 3 reduce, and you get 1 over 27. So it's 1 over 27, not 1 over 9. Okay? You have to expand any exponents before you reduce them. So that's 3. I'm just going to go through and take care of negative exponents. 3, x squared, the y cubed comes downstairs. I'm going to go through the bottom, I'm going to write that out, 81, x to the 4th comes upstairs, and y squared stays downstairs. So in this next one, this is going to reduce to 1 over 27, that becomes x to the 6th, and that becomes y to the 5th. Okay? This whole exponent says it's negative, and you got some negative exponents in there. I guess I would just move stuff. Or, how about this? This is this one, isn't it? And this inside is worth this. Why not just take it over and go x to the 6th, 27, y to the 5th, all raised to the negative 2. So that's going to be x to the negative 12. 27 was 3 cubed, wasn't it? It's 27. To the negative 2 becomes 3 to the negative 6th, y to the negative 10th. Notice all the exponents are negative, so they're all going to flip. So I have 3 to the 6th, y to the 10th, x to the positive 12. Okay. That just moves upstairs. X squared, z to the 4th. Nothing else to do. If they have a negative exponent, move it. If it has a positive exponent, leave it alone. Sometimes it's helpful just to go through and move stuff right away. Y to the 4th, so I just went through the top. Now go through the bottom, times 2, and the z cubed comes upstairs. So that will give you 10, y to the 4th, z cubed, over x squared. Okay, 0 as an exponent. Just to work this out for you, that's 3 times 3 times 3. That says how many times you multiply the number together. Well, what does this mean? Multiply it by itself no times. Multiply it by itself a negative 1 times. I don't get it. Well, one way to visualize it is to go from this level to this level. I'm going to take this answer and divide it by 3 to get that answer. To get this answer, I'm going to take this one, divide it by 3, and I get that answer. To get this one, divide it by 3, and you get 1. Take this answer and divide it by 3, and you get a third. So that's a way to motivate how these work. Okay? Another way to give you what 0 is worth. If you had 3 to the 5th over 3 to the 5th, you know the top is the same as the bottom, you know it's worth 1. Well, writing it out, saying 3 times 3 times 3 times 3 times 3 over 3 times 3 times 3 times 3 times 3. All these 3's cancel out, and when you cancel numbers, a 1 is left in their place, so it's worth 1. Okay, I think that's the last screen. So there you